I'm Mr. Fransky here. I had a request about using calculator on some of the Rainbow Review problems we had for Chapter 4. So I'm going to do the ones that said they require a calculator. And so today students will be able to use a calculator to solve f prime, and f double prime problems. Let's use a little less offensive color here. That'll work. All right. So key vocabulary, graphing. We're going to talk a lot about graphing today and how powerful that can be. First derivative, second derivative, maximum, minimum, increasing, decreasing, inflection point, and concavity. So we're going to be able to do all of these things using our calculator and by looking at graphs. So this is just directly from the Rainbow Review. These questions require a calculator. So use f of x equals x squared times 3 to the x on negative 3, 3. That's a closed interval, and this function is continuous on that interval. Use calculus to find the absolute and local extreme values of the function, correct to 3 places to the right of the decimal. 3 places, remember, is the really important number of decimal places we need for AP to be able to get correct answers. So I'm going to start with this by doing a candidates test. I need to find critical points and endpoints. So critical points and endpoints. Endpoints I know, right? So these are my candidates that could be my possibilities. So I have negative 3 and 3 for sure. Now let's see if we can find any critical points in the middle. I have to find when the derivative is 0. So the derivative here, I have to use product rule. 2x, if I take the derivative of the first function, times 3 to the x, plus, this time I leave the x squared alone, I multiply by the derivative of 3 to the x, which is 3 to the x times natural log of 3. Now I want to know when that's 0 or undefined. So what I'm going to do is I'm going to go to my calculator and just graph this function. So I'm going to check over to my calculator here. Deep. Oh, come on. All right, so we're going to my calculator. I'm going to just turn it on and go to my documents. And then I'm going to scroll down and I'm going to choose my AP Calculus BC document. If you haven't made one of those, make sure you watch the video about how to do that, because you're going to want to make sure that you're able to have all your settings the way that you want them to be. So now what I'm going to do is I'm going to hit on. I'm going to hit add a graph. And I'm going to graph. Looks like we already have a graph in here. Great. I'm going to graph our function. So it was 2x times, and make sure you use multiplication when you're doing this product stuff, because it doesn't love when you multiply by 3 to the x by using just parentheses. Okay, arrow over to get out of that, and then I do plus. So it'll be this time x squared. So x squared times 3 to the x times ln 3. 3 to the x times ln 3. Get out of there. Times ln is right here, ln of 3. Okay, all right, so I'm going to hit enter on that and get our graph. So I'm looking for our zeros between negative 3 and 3. So I might use a zoom box here. So I'm going to go to menu, go down to zoom. Let's see here. I'm going to do a zoom box. Zoom box is my favorite. First corner up here, somewhere over there. Second corner down here. There we go. Get a nice picture of the box, or the graph. So what I have now is, I'm looking for these two zeros we have right here. It looks like we have a 0 at 0, which makes sense because we have a 2x and an x squared added together. Looks like it's also a 0 over here. So I'm going to go back to, let's see, find my analyze graph. And I'm going to find these zeros. So left side over here somewhere, looks like we have 1 0 right there. Let's find the other one, menu, analyze graph. Looks like we have it right at 0, but let's double check. Yep, right at 0, 0. Okay, so I have my 2 spots. Now, there's something else I can see from this graph, right? Another thing I can see from this graph is that this is the derivative, right? So prior to this first 0, what kind of derivative values do I have? Well, they're positive. So that means the graph of f would be increasing over here, right? This is the graph of f prime. I don't care about this graph. I care about the graph of f. So we go from increasing function to a decreasing function, right? Positive first derivative to a negative first derivative. So that's going to be a maximum right there. And then 0 over here looks like it's going to be a minimum because we changed from negative derivative values to positive derivative values. This is why this graph is so valuable. I don't have to do any plugging in of numbers. I can just look at it. Positive, negative, positive. So let's go make our number line. I have to remember this one. Negative 1.82048. So write that down. Negative 1. Oops. So we had negative 1.82048. I hope that was right. Negative 1.82048. Yep. Okay. So number line, we're back to red. That's okay. Negative 1.82048 and 0 were our 2 critical points. And 0. And we saw that the derivative change was from positive to negative to positive. We saw that just by looking at the graph, right? Positive to negative, positive. Cool. So that means we have a maximum at negative 1.2048. And we have a minimum at 0. And we must start at a minimum if we rise to initially, and then we must end at a max if we rise at the end. But we have to actually figure out what these values are. So what I'm going to do is just plug them into my equation. I'm not going to do that now, just for the interest of time. But I would plug negative 3 in here. I'd plug negative 1.82048 in here, plug 0 in here, plug 3 in here to see what those values actually get me. And then I'm going to be able to see which one's the absolute max, which one's the absolute min. Just wanted to talk you through graphing the derivative there. So go to the next one. The derivative of f is given by this guy. At which x values does f have a relative maximum value? So I'm looking for where f has a relative maximum. I'm going to do exactly the same thing here. I'm going to graph this, 2e to the x minus 5x squared. Let's do that. So I'm going to just hit tab. I'm going to go up, and I'm going to uncheck this, so I'm not going to see it anymore. Now I'm going to go back down, so I'm doing a new graph here. So it was e to the x. Got to do e on next to the pi over here. Make sure I get the correct e. So e to the x, what was it? Minus 5x squared. Minus 5x squared. Okay, graph that. Get rid of some of these. No, we'll leave them there. That's fine. Okay, so we're looking for x values where f has a relative maximum. So x maximum happens when the derivative changes from a positive value to a negative value. The only place that happens is right here. That's the only spot it happens. So what I'm going to do is go to Menu, Analyze Graph. I'm going to find the 0, right? Because this is the derivative graph. I don't care about this graph. I care about f. I'm going to find out what that 0 is right there. Looks like that happens at 0.605267. So x equals 0.605267. And why is that? Because f prime of x changes from positive to negative. Okay, that's it. That's all there is to it. It's 2e to the x, shoot. And that's going to change things. Okay, let's go back. 2e to the x minus 5x squared. There we go. So it's going to be a little bit different. Let's get rid of these things. Move them over. Okay. These are from my old graph. So if we go to Menu, Analyze Graph, find the 0, cross over it right there. There we go. 1.09162. Let's get rid of this. Uh-oh. There we go. 1.09162. Because f prime of x changes from positive to negative. If I graph the right function, it would be a little bit better, right? All right. Let's take a look at the next one. Verify that the function f of x equals sine x satisfies the hypothesis of the mean value theorem on the interval 2, 11. Well, it's continuous on closed to 11 and is differentiable because sine is continuous and differentiable everywhere, but open to 11. Good. Okay. And then approximate 3 decimal places, all places between 2 and 11 that satisfy a mean value theorem. So we have to find the slope. So sine of 11 minus sine of 2 divided by 11 minus 2. So we'll use our calculator to do that. Go to our calculator window, and we're going to do sine of 11 minus sine of 2 divided by 11 minus 2 is 9. Okay, and we use Control Enter to get an approximate value, negative 0.212143. Okay, so to do mean value theorem, I have to find out when the derivative is equal to that. I have to find out when the derivative is equal to that value. The derivative of sine is cosine, so I want both sides, and you got something like x equals 1.7. What's wrong with that, though? Mean value theorem guarantees it's on the interval. This is not. So you could mess around with identities, try to add pi, subtract pi, add 2 pi, I don't know. But I think an easier way to do it is just graph this thing. Let's graph cosine. Let's graph negative 0.212143, and let's see where they intersect. So go back to my graph here. I'm going to add a new graph, actually. Let's see if they'll let me add a new one. Yeah, I want to get rid of this. Control up, see all my tabs. I want to clear out this graph. Actually, it cleared it out. Okay, that's fine. So I'm going to graph cosine x, and I'm also going to graph negative 0.212143. I just want to know when they intersect, and I want this to be from 2 to 11. So I'm going to go to Menu, Window Settings, change from 2 to 11. And now I'm going to do zoom fit. So I'm going to Menu, zoom fit. Remember, you have to change your x's before you do that. So now we have a great picture from 2 to 11. Looks like there's 1, 2, 3 places it happens. Go Menu, Analyze Graph, Intersection. And if you need help with doing all this stuff, go ahead and watch the other videos about using your calculator because they're really useful. So it looks like it happens at 4.49862. So it happens at x equals 4.49862. Also happens, Menu, Analyze Graph, Intersection. Also happens at 8.06775. Remember, we need at least 3 decimal places. 06775. And one more. Menu, Intersection. Right at the end there. Sneak it in there. 10.7818. 10.7818. All right, there are 3 values between 2 and 11 that work out. I think I got one more. Oh my goodness. Oh, that stick around. That's weird. I don't want to erase either. Okay, well, it's going to stay there. Oh, there we go. So, graph of the function y equals 1/3 x cubed minus 2x squared plus minus 5x plus 3 sine x changes concavity at what x coordinate. So what we have to do here is on y double prime to change sign. To change sign. Okay, so let's do the derivative here. Y prime is going to be just the 3 comes to the front, cancels with the 1/3. So we have x squared minus 2x minus 5 plus 3 cosine x. So y double prime then will be 2x minus 2. The 5 goes away, and we'll have minus 3 sine x because the derivative of cosine is negative sine. So what I'm going to do is graph this. Okay, 2x minus 2 minus 3 sine x. Back to on, add a graph. 2x minus 2 minus 3 sine x. All right, here's our graph. Looks like we only have 1, 0. Right, 1, 0 right here. And it does, this is the second derivative, remember. It changes from a negative value to a positive value up here. So let's find that 0. Menu, Analyze Graph, 0, crossover, 2.20675. 5, there we go. Because f double prime of x changes, changes from negative to positive. You don't really have to say it's negative to positive, but it changes. Just the fact that it changes, that's an inflection point. It changes concavity. Nice. All right, that's all I've got. Learned a little bit about how to use your calculator, and it'll be useful on your test. Love you guys. That's why I'm here. Have a great day.